Okay, we are now on example number 8. Example number 8, you can see the beam on the board. So you see it is a combination of UDL and what? VDL. That is uniform distributed load and variable distributed load. So now for you to solve this question, anytime you see a question like this, the first thing you need to do is you have to find the point that they intersect. You see they intersect at this place, right? So if you see at this point of intersection, this straight line that is coming, I can still trace it out. Then you will see it will be in form of something like this. Be like this. You go like this. So this is the first thing you need to do if you see a question like this. So now you see that it is a uniform distributed load running from point A to point B. First thing you need to note. So now you see the variable distributed load is from this point there to this point, and it's covering a distance of what? 3. While the uniform distributed load is covering a distance of what? 6. Do you get that? So now the next thing you need to do is we are going to convert them to point load. So now let's go for uniform distributed load first. UDL. So now for UDL, for you to convert it to point load, you consider the area of a what? The rectangle, that is length, the total length times what? The weight. So now it's going to be what? 6 times 600, which is what? 3,600 Newton. So and don't forget, anytime you convert a uniform distributed load to a point load, it's going to act at what? The center of the what? Of the beam. Do you understand? It's going to act at the center of the beam of the length of the beam. You see, it's running from here to here, and the length is what? 6. It means it's going to act at what? The middle point. Do you get that? Now, but for variable distributed load, VDL, so now the area is going to be what? The area of a triangle, which is half base times height, which is half times base. The base is what? From this point to this point, which is what? 3 times the height. Now, is the height 900? No, it cannot be 900. From this point to this point is 900. And from this point to this point is what? 600. So it shows that from this point to this point, which is the height of the variable distributed load, is going to be 900 minus 600, which is what? 300. So this place will be what? 300. So which is nothing but what? Which is nothing but 3 times 3 is what? 900. 3 times 300 is 900. 900 divided by 2 is 450. So now, gotten that. And it's going to hurt. This 450 now that you have converted to a point load is going to hurt at what point? Now, I've already explained this in introduction to beam. You have to bring out your angle 90. You see, we are going to have our what? Angle 90 degree at this point. You get that? And it's going to hurt at, it's covering a length of what? 3. So it's going to hurt at what? L over 3. That is the center. That is the center. You can say C is equals to the center that which this 450 is going to cover is L over 3, away from what? 90 degree. Do you understand this angle? So now, and our length that is covering is what? 3. So it's going to be 3 over 3, which is what? 1. Shows that it's going to cover 1 meter away from what? 90 degree. I hope you get that. So now, let's draw the free body diagram. And don't forget, this one is going to be what? Arrow A, reaction at A. Don't forget it's a roller support. This one is a fix. It's going to have 2 reactions and HB. So now for the uniform distributed load, it's going to have half of what? The center of the what? The beam, which is what? 3,600 Newton. And don't forget that this place is 3 meter and this place is 3 meter. Don't forget that this one is variable distributed load, which is 450. It's going to add 1 meter away from 90 degrees. So let's say from here to here is 3. So 1 meter will be here. So 450 Newton. So this point will be what? 1 meter. It means this point will be what? 2 meter. You get that? So please take note of that. So now the next thing we need to do now is to take our moment and take our sum of horizontal force, which is equals to 0, then HB will be equals to what? 0. So let's take our sum of vertical forces, which is equals to 0. So it shows that we have four forces here, and ROA and ROB, they are upward force. We say let them be positive. So ROA plus ROB minus 450 minus 3,600 equals to what? 0. So ROA plus ROB will be equals to what? If you add this and this, add 400 to this, you are going to have what? 4,450. No, 4,050. So 4050. So equation number what? 1. So the next thing now is to take our moment. So take our clockwise moment. MA equals to what? 0. So let's take our moment now. Yeah. So if I'm taking our moment, means our downward force here, we produce a what? Clockwise moment to be what? Positive. So it's going to be 450 times what? Times the distance is covered is what? 1 plus 3,600 times the distance is covered, which is what? 3 minus ROB times the total distance, which is what? 6, which is equals to what? 0. So now it means that 450 times 1 is 450. 450 plus 3,600 plus 3,600 times 3. 3,600 times 3 plus 3,600 times 3. Okay, let's do that somewhere here. I'm now with calculator here. 0, 0. 3 times 6 is 18. Carry 1. 3 times 3 is 9. 9 plus 1 is 10. So it's 10,800. 10,800 minus 6 ROB equals to what? 0. So when we add this together, we are going to have what? We are going to have 10,800 plus 450. I think I've solved it here. That is 11,250. 11,250. So 11,250 minus 6 ROB equals to 0. When this one cross here, 6 ROB equals to 11,250. So ROB will be equals to 11,250 over 6. So if you divide this, I think I already solved it here. 11,250 divided by 6 is 1,875 Newton. 1,875 Newton. So now, can we get our ROA? Yes, of course, we can get our ROA from this equation 1. ROA will be equals to, this ROA will cross to this side, which will be 4,050 minus ROB. And our ROB is what? 1,875. So ROA will be equals to what? 4,050 minus 1,875 is nothing but what? 2,175. 2,175 Newton. So don't forget they can equally ask you to calculate your resultants and your angle of inclination. I've explained that in my video. For you to get that, you know what to do. So thank you. We stop here. Example 8. We move down to what? Example 9.